The paper is Scalable Garbage Collection for In-Memory MVCC Systems. It's a 2019 paper. This paper showed that the garbage collector is a crucial component of an MVCC system. Its implementation can have a huge impact on the system's overall performance as it affects the management of transactions. Thus, it is important for all cases of workloads, not only mixed but also garbage-heavy workloads. Their experimental results emphasize the importance of GC in modern many-core database systems. As a solution, they propose Steam, a lean and lock-free GC design that outperforms previous implementations. Steam prunes every version chain eagerly whenever it traverses one. It removes all versions that are not required by any active transaction but would be missed by the standard high watermark approach used by most systems. Now let's look at the benchmarks used. They use CH benchmark. The CH benchmark is a challenging stress test for GCs because its short-lived OLTP transactions face long-living queries. Then the second one is TPCC. TPCC is a pure OLTP benchmark without the long-running transaction that could lead to the vicious cycle of garbage. Paper shows the importance of garbage collection for in-memory MVCC systems on modern-day many-core systems. Authors find that GC should be based on thread local data structures and asynchronous communication for optimal performance. Further, it is crucial for HTAP workloads for short-lived writes and long-running reads to keep the number of active versions as low as possible. With traditional high watermark-based approaches, a single long-running transaction blocks GC progress during its lifetime. The novel scalable GC Steam speeds up transaction processing and garbage removal by pruning all obsolete versions eagerly whenever a new version is added. Thereby, Steam effectively limits the length of chains to the number of active transactions. Besides HTAP workloads, their experimental results indicate that Steam benefits all kinds of workloads from write-only to read-only. Its seamless integration into transaction processing enables superior performance compared to other state-of-the-art GC approaches which detach GC from transaction processing. Now let's give this paper a PS score. It's nice and engaging read, so it gets 9 out of 10 on readability. With 14 pages long, it gets 9 out of 10 on length. Reproducibility is high, so it gets 9 out of 10. Industry value is decent as the GC approach is pretty novel, so it gets 9 out of 10. There are neat ideas around GC, so on Learning Meter, it gets 9 out of 10. So the overall PS score is 9 out of 10.